Hi everyone, welcome to this tutorial about motion capture in Unreal Engine. Today I'm gonna show you how to animate a head using motion capture in Unreal Engine 4 under Windows and using a free Android application. At the end of this tutorial you will be able to see a virtual head following your own movements like this. For this tutorial you need to use Unreal Engine 4.26.1 minimum. Why .1? It's because there is a bug in .0 preventing you from linking a skeletal mesh with a control rig in C++. You also need to download the MetaHumans project from the Unreal Engine 4 marketplace, since we are gonna use the MetaHumans head in this tutorial. But you could do exactly the same thing using any skeletal mesh you want. Finally, we will use a face Mocap application developed by MotionMX, available for free in the Play Store, and you will have to connect your phone and your computer on the same Wi-Fi network. You can find the link of this application in the description below. Okay, so we're gonna start by creating a blank C++ project. For this tutorial we use some of the MetaHumans assets, so once our project is created, open the MetaHuman project to migrate the assets we need into our project. We'll use MetaHuman 001 that is in content sample MetaHumans, MetaHuman 001 face. We only need to migrate this asset because Unreal will migrate all its dependencies, we don't have to do it manually. For that, we right click on the skeletal mesh, asset action, migrate. This window will open, it can take a few times, just click on OK. And then select the content folder in which you want to migrate the assets. So we select the content folder of our project. And now in our own project, if we explore the sample MetaHumans folder, we can see that the assets are there, but we can't see the skeletal mesh, even if we can see it in the file browser. That's because we have to activate a plugin. So go to Settings, Plugins, search for Rig Logic and enable it. We're gonna also enable the Control Rig plugin since we're gonna use it later. These plugins are in a beta version, so a warning pop-up will show up, but we still can use it, so just click on yes. Then just restart the engine. And now we can see our skeletal mesh. If you click on the skeletal mesh, a warning pop-up will show up saying that there are missing project settings. Click on enable missing. Unreal will do the job. And then restart now. And that's it. To control the movement of the head, we're going to use the control rig. To create one, you can right click on the skeletal mesh and click on create control rig. You can also right click on the content folder, click on animation, control rig. Select control rig, create, and name it as you want. I will name it MetaHuman 001. If you have created your control rig with the skeletal mesh, you can open it and you will see that everything is already set up. But if you have created the control rig by clicking in the control folder, you'll see that there is no mesh in the control rig. You have to import it, so click on Import Hierarchy and select your skeletal mesh. And you can see that our mesh is imported and all the skeletal mesh is there. Now that our control rig is created and set up, we have to create a control. We're simply going to start by creating one for controlling the direction in which the head is pointing to. For that, right click on the hierarchy, then new and new control. Let's name it head target control. We set the offset transform to 0.35 150. for the location in order to place it at the same level as the eyes. We'll also need to reduce the scale of the gizmo because it's slightly too big. That's it. Now that we have our control, we have to link it with the different bones. For that, let's move on to the rig graph. We're going to use the node aim. We will set the bone name to head. That is at the end of the list. This looks strange for now, but don't worry, we just didn't set all the parameters yet. We now need to give a target to the node. This target is our head target control position. So let's get its transform using the get control transform node. We set the control to head target control, and we get its translation and set it to targets. Let's compile. If we move our control, we can see that the head is following, but it's not actually looking at it. That's because we need to set the target axis. This tells the control rig which axis of the head needs to be aligned with the control. In our case, we want to be aligned with the y-axis. Now the head is looking in the right direction, but the neck is broken. That's because we need to set a secondary axis. It's a direction, and the axis, known as up vector or pole vector, is x in our case. If you want to know how to identify the axis you have to use for alignment and that for the up vector, first you have to remove the aim node to check the head in its normal position. And then select the head bone name. There he is. We will maximize the viewports. If we move just next to it, we can see there that the green axis corresponding to y is pointing to the control point, and the red axis corresponding to x is pointing up. So we know that our forward vector is y and the up vector is x. So let's link again the aim node, compile, and if we select our controller, we can see that the head is following the point. In order to measure the movement of our head, we use the Face Mocap Android application available for free in the Play Store. We capture our face motion with our phone through this app by detecting key points. This application is not as efficient as some other apps, but it's a good start to do Face Mocap on Android for free, because a larger majority of good motion capture applications for Android are very expensive. To connect the Android app with our application, we're going to use a TCP connection. The Transmission Control Protocol (TCP) is a protocol that provides reliable, ordered, and error-checked delivery of data streams between applications. We're going to have to connect our phone running the Face Mocap app and our computer running our Unreal app to the same Wi-Fi network. Then we're going to connect a socket to the Android app. This socket has a buffer in which our phone will send us data packages. We're going to need to read this buffer to get the motion capture data. Now we need to connect our program to the app. For the sake of performance, we are going to use C++ for all these parts. First of all, we need to go into the file name of your project.build.cs to add the correct module dependencies. For me, it's tutorfacemocap.build.cs. In the public dependency module names, we should add sockets, networking, and control rig. We're going to code the network system in a game instance class. This will allow us to keep the connection between the different scenes. So let's create a game instance in C++. First, we need to define some variables. We set a string for the socket name. It's not the most useful variable here, but it's always better to be able to choose the socket name by ourselves instead of hardcoding it. Then we set the max buffer size as an integer. We set this max buffer size by default to 2 megabytes. I think that auto reconnect is clear enough. You just have to set it to true if you want to automatically retry the connection when the last one failed. We also need to store the IP address we want to connect to as a string and the associated port as an int. The default values of these two variables are available in the face Mocap application. You can see on the bottom of the screen that there are the IP address and the port. Finally, we need to store the remote address and the sockets. The remote address is not really useful to store in this particular tutorial, but it might be useful depending on which features you want to add, like the connection system for instance. ISConnected should be understandable and just describe if the connection is currently set. We're gonna add a public getter for this ISConnected boolean. We're gonna make it a ufunction blueprint callable because we want to be able to call it in blueprints. Now let's declare the public functions that we'll need in the following. They all will be blueprint callable. So we're gonna have a connect function with no parameters, and we also need a connect to server function having an IP address as string and a port as int as input parameters. These two functions do the same thing, but in the second one we can change the connection parameters, while the first one uses the parameters stored in the class. Since the parent game instance class has no tick function we can override, we have to manually call a given function to update the network. Therefore, we're gonna implement an update network function that we're gonna call directly from our game mode to ensure the correct update. Finally, we add a disconnect function that will disconnect our socket from the app. We will override the game instance shutdown function to call the disconnect function when our application is closed. Finally, we are going to add some events where the user can bind his own functions to be notified. We consider here the event onConnected, onConnection failed, and onReceived package. Obviously, you can add as many events as you want, but for this tutorial, this is enough. We don't have an onConnection lost event because the socket does not detect when it loses the connection. It seems like the face Mocap application doesn't notify the socket that it is disconnecting, so the state of the socket doesn't change and we can't try to reconnect. But we could implement a timeout system in order to detect disconnection, but it's not our goal today. Since we want to use our own event types to call it and send information the way we want, we need to implement our delegates to reference and execute our callbacks. Here we're gonna declare two dynamics delegates. The first one doesn't need any parameter. We enter the name of the delegate we want. You are free to set your own name, it doesn't matter. We're gonna use it to notify a state change like onConnected or onConnection failed. The second one takes one parameter. We set the name, then we precise the type of the parameter and the name of the variable. We're gonna use it to send the package we've read into our code. Let's move on into the CPP and start the implementation. First, getIsConnected just returns isConnected because it's just a getter. The connect function is simply a call to the connect to server function with IP address and port as parameter. For the next functions, we will need to include two headers, sockets.h and socketsubsystem.h. In Connect to Server, we start by notifying the user that we are trying to connect using a message log. Then we get the socket subsystem of our platform and we create the remote address. We create a boolean that is gonna tell us if the IP address is valid. We set the IP address and the port in our class and in our remote address. If it's not valid, we log and we return. Else, we create a socket using the socket subsystem. Then we set its receive buffer size. Then we set the socket to non-blocking to avoid the socket to block the execution while waiting to receive data. And finally, we connect the socket to the address. And now it's time to work on the update. First of all, we check if the socket isn't a null pointer. The socket has a state that you can get by calling the function getConnectionState. This will tell us if the socket is connected, if it's not, or if the last connection failed. So we make a switch with the socket's connection state. If the state is SCS connected, we print a log for debugging. If M is connected is false, that means that we've just connected, so we change M is connected to true, and we broadcast the event unconnected. If it's SCS connection error, that means that the last connection failed, so we log an error message. We broadcast the event unconnection failed, and if M auto reconnect is true, so if we want to automatically try to reconnect when the last one failed, we log that we are trying to reconnect and we try to reconnect the socket to the remote address. And by default, we break. In this function, you can see that I'm using a print string function. It's useless to look for this function, you will not find it because I've written my own function that you can copy paste. This function simply prints a string on the screen and in the logs. And finally, the disconnect function only closes the socket if the socket isn't a null pointer. And this disconnect function is called in the shutdown function, that is an override function which is called when the application is closed. Do you remember when I told you that we will need to call the update network function in the game mode? It's time to do it. So let's create a game mode. We need to store a pointer to the game instance to avoid getting it for each frame. We also need a constructor, a begin play, and a tick function. In the constructor, we simply set the pawn and the HUD to null pointer. In the begin play, we init the game instance, and in the tick, we call the update network functions of our game instance. Don't forget to set the game instance in the project settings. I've made a simple lobby which allows us to enter an IP and a port and to connect to the server with a button. So now we're gonna create a connection lobby map in order to test the connection. We don't need to put anything on the scene, an empty one will be enough. We have to go into world settings and to set our tutor-face Mocap game mode. Now we have to go into the project settings and to search for game instance. And finally, we have to go into the blueprint, the level blueprint, and to create a widget. And it will be our connection lobby widget, and we have to link the player controller and add to viewports. And now if we open the load, we will clear, and if we press play, Don't forget to be on the same Wi-Fi as your phone and to launch the Android application. If we click on connect, it will connect. Now that we are able to connect to the Face Mocap app, we need to read the packages we are receiving to interpret them. Let's return to our game instance and append 3 private functions to the header file. Read buffer will manage the buffer reading process using the read header and the read data functions to read the specific data stored in the buffer. Let's start with the read buffer function. We're gonna start by printing the receive buffer content for each frame to check what the data looks like. So we need an uint to get the size of the buffer using the function hasPendingData. Then if there is pending data in the sockets buffer, we need an array to get the data as a bytes array. The variable bytes read is needed to get the size of the array we get from the buffer. Then we need to set the size of the array that we will use to get the data from the buffer. Then we read the data from the buffer. I will explain to you later what issocket receive flag is used for. And now, since we want to log the package, we have to convert the array of uint8 into a f-string. Let's try it, but before that, we now need to call the function readBuffer in the update network function. So we have to call it when the socket is connected. And let's compile. So now we can try to read the buffer. So press play, open the Android application and press connect. We don't need to let it run too long. It's a bit laggy when it's running, that's because we are printing a lot of data in the output logs. So if we open the logs, you can see that we are printing a lot of data. For the moment, we can't read anything, and that's because the data received are bytes. So in order to read it, we have to convert it into a readable string in ASCII. So let's return into our readBuffer function, and we have to change this function. We can delete that. And Unreal has a function that converts an array of bytes into a string. This function is called bytes to string. And we have to send it the package data the size of the package. The fun fact is that this function is not working properly, and this problem has been reported many times over many years. The problem is that the Unreal native function returns the expected value but incremented by 1. This line, add 1 to each character. So we have to do our own bytes to string function. Fortunately, it's really easy to do. I've done this function in utilities.h together with the printString function. We are using a const reference of t-array of uint8. We loop on each character and we finally append the character into a string. And then we return the string. So let's try it. We can remove all of this and only send the package directly. So let's compile and try it. So if we press play and click on connect, and we can stop. Let's see what it looks like. This is way easier to read. With these logs, we can examine the formatting used to store the data. Each package starts with a header. Each header starts with a question mark and is followed by 4 numbers. Indeed, the header size is 5 bytes, 1 for the header specifier, the question mark, and 4 bytes to describe the package size. This is how it looks. Then there is the package content that is composed by vectors. And if we scroll, we also see that sometimes the log doesn't start with a question mark. That's because we read the whole buffer each frame by removing the data from it. But sometimes a package isn't completely written in the buffer during the delta time. So we get only the first part in a frame while the end is read in another frame. I will explain to you later how to manage these incomplete packages. Now let's implement the functions allowing us to read and send packages in our app. First, the readHeader function. We're gonna use the outPackageSize variable to return the size of the package read in the header. As we have already done in the readBuffer function, we also need an array to read the data stored in the buffer and an int32 to get the size of what we've read. We need here the size of our header array. Then we are reading 5 bytes in the buffer. 5 is the size of the array and the size of the header. This time we use the eSocket receive flags pick, allowing us to read in the buffer, avoiding removing the data that we are reading. We check if the first character is a question mark. Normally, if all our code works, it is supposed to be always the case, but we never know. So for more security, if the first character isn't a question mark, we return false. So we will be able to check if there is a complete package or not. Then we create another array of bytes excluding the question mark. We convert it into a readable string, then to an int, and finally to an uint32. We eventually return true to notify the user that we've correctly read the header. Now we have the size of the package, so we can read it. Let's move on onto the readData function. Once again, we need an int32 to get the size of what we've read in the buffer. We init the size of the array containing the read data. We are using package size plus 5 because we have to count the 5 first byte of the header, because remember we used the pick flag, so these bytes are still in the buffer. We then read the data in the buffer, but this time we remove it as we read it. That's done using the eSocket receive flag none. Finally, we remove the 5 first bytes corresponding to the header because we only need to keep the data. Now we can use these functions in the generic readBuffer function. We can now replace the if by a while to read the buffer until there is no more complete package, and we can remove everything in the loop. Then we need a uint32 to get the size of the package. We call the function readHeader, we send package size in parameters, and we check what the function returns. Normally it should always be true, but if it's false, we print a log and we return. Finally, we check if the package we want to read is completely in the buffer. Once again, we have to add 5 because the header is still in the buffer. If it's the case, we read it using the readData function and send it to the functions linked to the event onReceivePackage as string. Else, we return because we have no more package to read. To check if our functions are working, let's create a function and link it to the event. So I've created a function corresponding to the delegate we declared. Be careful, this function has to be a function or it will not be called by the event. So in this callback, we simply log the package. Now we have to link this callback to the event. For that, we have to override the public function init and in the CPP in the init function, we take our onReceive package events and we add dynamic our function onReceive callback. And now we compile. So once we've compiled, we can press play and test. If we go into the output logs, that works. Package received and the package. You can scroll a bit. Sometimes we can see that there is a multiple package in one frame. So let's add a little optimization in our function, because actually we send each complete package which is in the buffer each frame, but in our case we will not need to have all the packages. We just need to get the last one. So in the read buffer function, we can move our data declaration on the top of our function above the while loop, and move the sending of the package outside the while. But we have to check if there is data on the array. Don't forget to replace the return by a break to exit the loop instead of exiting the function, or this event will never be called. Like this, we will read all the packages in the buffer and store the last package we read in the array. When we exit the while loop, that's because we have reached the end of the buffer and there is no complete package left. So if the variable package that stores the last package read is not empty, we send it. And if we test, we can see that there is only one package each frame. Each time we can see a package, we can see also a connected log. So we can now clear the debugs. So remove the callbacks, remove the init function, and same in the header. And we can move this print and print it only one time when we've just connected. Now we are able to receive and get the packages so we can use them. Before linking it with the control rig, we're gonna display a cloud of dots to see all the points the Face Mocap app is sending us. Let's create a new scene. We set our game mode in the world settings. Now we need to create two classes inheriting from a actor. One will be a cloud point corresponding to a point from the face. The other one will be the clown manager. We also need a material for our point, so let's create one. We don't need something complicated, just a color applied to the base color and emissive color. We need our color to be a vector parameter to be able to change it at runtime. Let's start with the point class. There are not many things to do in this class. We need to store a mesh and a material. The mesh is a uStatic mesh component. The material is a uMaterial instance dynamic because we want to be able to change its color at runtime. We also need a uMaterial interface to store the material assets until we create our material dynamic instance. We only need the constructor and the begInPlay function, and we need to implement the setColor function for changing our material color at runtime. In the constructor, we create our mesh component that we're gonna also set to our root component. Then we search for the assets for the sphere mesh and the material for representing each point. We then check if we successfully found them and we set them to the mesh component. Then in the begInPlay, we simply check if the material asset exists and we create a material dynamic instance that we then set it to the mesh. The setColor function simply sets the vector parameter color of our material to the color we want. Now we can move on to the point cloud manager. First of all, we need an array of points. Then we need to know in advance how many points we want to create. So I've created an editable int. And finally, we need two colors to distinguish a selected point from the other points. As for the point class, we only need the constructor and the begInPlay function. The most important function here is onReceivePackage callback linked to our game instance. This function must be a U function, otherwise it cannot be called by the game instance. The begInPlay function is in charge of spawning the various points. For this we need a F-factor spawn parameters, and we set its owner to this. Then we loop on the total point number m points count. For each point we set the spawn parameters name to point_i. Then we spawn an actor. We attach it to the point cloud manager, so we attach it to this. And we set its label equal to its name. And finally, we set the color to unselected point color, and we add the point to the array. Once done, we get our game instance, and we link our callback to the game instance event. We might have connected the game instance in the menu, as we've done earlier, and then switched to this level, but it's slightly more work to do, and we don't need it for this tutorial. This way is enough for us, so we connect in the begInPlay. Finally, let's talk about the onReceivePackage callback. We first create an array storing all the positions as strings. We then parse the package into the array we've just created. The delimiter is a pipe character. True is used here to specify that empty strings are not appended to the array. Then for each string in the array, we split it into another array. This time this array contains the vector coordinates. The delimiter is an underscore. And then we create a vector from this array by converting the string into a float. And finally we set the corresponding point position. We can now compile. Now that we've compiled, we can test. So let's go into our Mocap point cloud scene and add a camera. We place it to 0, 0, 0, and we rotate it to -90 degrees around the z-axis. I rotate the camera because I want it to face the y-axis. And I'll add a directional light because I want to see my camera. And now we can add the Mocap Cloud Manager and place it to 0, 0. And if we press play, don't forget to launch the Android application. We are connected, and you can see that I'm moving my head, but at first sight we can't see our points. That's because they are not correctly positioned. If we unprocess the camera and rotate down our view, we can now see the point cloud. Indeed, the Face Mocap Android application does not use the same mathematical referential as Unreal does. To fix this problem, we will have to make some rotations. So let's move into our onReceive package callback and apply rotations to the position. So we have to rotate it to minus 90 degrees around the x-axis. So f vector x-axis, and to rotate it again to 180 degrees around the y-axis. And now let's test. So now, if we press play, we can see that it's working. Our head is moving on the screen. But there is a few lags, as you can see. This is because the application sent us a huge amount of points, and we don't need all of them. We just want to make the head aim a point, and for this we only need two vectors, a vertical one and a horizontal one, as you can see on this picture. Using these two vectors, we are calculating the forward vector and use it to determine the direction the head is pointing towards. To determine which points are needed, we're going to add some functions into the point cloud manager and create a simple UI to interact with. In the point cloud manager, we need to store the ID of the selected points. Then we need to add three public functions that are blueprint callable. In these three functions, we simply set the color of the last selected point to the unselected color. Then we change the selected point and set its color to the selected color. We clamp the selected ID between 0 and the total number of points to ensure code robustness. And then we return the selected point ID in order to notify which point we have selected. Now we need to access the Cloud Manager from our menu, so we're gonna use the game mode for that. There might be a more proper way to do this, but since this is just for debugging purposes, it doesn't really matter. So we add a public variable that will store the point Cloud Manager. Once we've added the Cloud Manager into our game mode, we have to initialize it. So we will move into our Cloud Manager CPP and get world. We search for the game mode, so get authority game mode. We specify that it's a tutor face mocap GM, and we set it's point cloud manager to this. It can compile. Now we need a very simple menu to select which points we want to highlight. We only need a text box and two buttons, a previous button and a next button. The text box calls the select point function when a text is committed. The previous button calls the select previous point on click, and the next button calls the select next point on click. And now we can go into our level blueprints and create widgets, get player controller, select our point cloud UI, add to viewport, and I will add the set mouse show cursor to true because I don't want my mouse to disappear. So now we can test. If we launch the Android application and we press play in Unreal, we can see that there is 1 point in red on our face, and if we change it, the point will change. If I set 100, for example, it will change. I've already looked for the useful points among the cloud for our purpose. That is, control our skeletal mesh using the face mocap. We're gonna use the point number 284 for the left point, the point 54 as right point, 10 as the top point, and 152 as bottom point. Now we have identified the useful points. We're gonna link them to the control rig. For the last part of this tutorial, we're gonna create a new class inheriting from a actor. It also could be an a pawn, it doesn't matter, it depends on your need. In this class we have two components, a skeletal mesh and a control rig. We also have a movement speed and two additional vectors to store the targets. We are using two vectors because we want to get a smoother movement by layering the current target to the final target. Don't forget to include control rig component.h. This is why we've added the control rig build module earlier. As we've already done with the point cloud, we need a callback to link to the game instance. We also add a function converting a packaged vector, this a string, into a f vector. Then we need the constructor, the begin play, and the tick functions. In the constructor, we simply create the theme components. We attach the skeletal mesh and the control rig to the root component. Then we change the relative location because we want the head to be centered compared to the root component. In the MetaHuman project, the characters have a body, so the head is located higher. And finally, we map the skeletal mesh to the control rig. In the begin play, we set the current head target, we connect our game instance to the Android application, and we link our callback to the network. In the tick, we load the current head target to the head target, and we set the target to the control rig. We set up the position in the actor space. The get position from package slice inputs a packaged vectors as string, parses it into an array, the delimiter is an underscore, and returns the vector rotated. Finally, in the callback, as we've done for the point cloud, we split the package into an array of vectors as strings. But this time we select only the 4 useful points identified earlier to create vectors. The horizontal vector is built using the points 54 and 284. The vertical vector uses points 10 and 152. Then we simply compute a cross product between the vertical and horizontal vectors. Be careful, the order is important. If you invert horizontal and vertical, our forward vector will also be inverted. Then we normalize the forward vector and we set it to the head target. Now let's test our code. Let's first create a new scene. We simply need a camera, a directional light, and our mocap face. We place the camera and the light in our scene. We then place our face in the scene. We set the mesh and the control rig assets. We set the camera to player 0. And don't forget to set our game mode in the world settings. We can now launch the Android application and the simulation, and we can see that our head is following our own movements. And that's it. We now have a simple face mocap proof of concept for Android. You can now upgrade it by adding more complex movements like head rotations or mouse movements. Thanks for watching this tutorial. If you have any question, please do not hesitate, the comments are here for that. Don't forget to like and share if this tutorial helps you. Bye.